Okay, here we are in our first section for 1-6, evaluating ordered pairs. Now in our very first example, we have y equals 8x plus 13, and we want to evaluate where x equals -2. And you're probably thinking, hey Mr. Hastings, we did a video like this in our last lesson, but I promise, stick with me, I'm going to add some new things. Okay, so let's check it out. We know when x equals -2, we will take y equal to 8 parentheses plus 13, and of course we can choose literally any other color here. We're going to be plugging in this -2. Now from here we know y is equal to, well of course 8 times -2 would be -16. A positive times a negative is a negative. So -16 plus 13. And we're going to say this, y is equal to, well, -16 plus 13 would be -3. But how do we write this solution as an ordered pair? Well, we know that every ordered pair is made up of an x and a y, and in this case we have -2 comma -3. Now what I'm going to ask you in this section is to pick the correct ordered pair. So let's say I have something like this, and our line would really and truly look something like that. Okay, so here is -2, 1, 2, 3, and here is this point. In question, when we have a point that's on a line, what do we call it? Well, we're going to call it a solution. And not only is it a solution, it creates a true statement. We're saying, hey, when we plug this in, we get a true statement here, -3. Well, what if I said, hey, is this point on the line -2 comma 4? 1, 2, 3, 4. Well, we see that this point is not on the line, and so we'd say, hey, that is not a solution. And by the way, from here on out, I'm going to abbreviate solution with SOLN. Pause here if you need to finish taking the notes, and let's move on to our next example. Okay, here we have example 2. And for example 2, let's say this. We have f of x is equal to -4x squared plus 2, where, let's just go ahead and say x will be 5. Alright, well we know we wanted to start by replacing our x's with sets of parentheses. And let's go ahead, I really like that purple here, I think it pops out. So let's go ahead and plug that in. And we can say this, f of 5 is equal to -4 times 5. Let's see, what would that be? That would be, oh wait a second, am I making a mistake here? I almost forgot about our square. Don't forget, we always have to square things first. So we really have -4 times, and remember 5 squared is 5 times 5, that would be 25. Ooh, almost a silly mistake there, Mr. Hastings. Okay, well we have -4 times 25, which most of y'all do know is -100 plus 2. And of course from here, f of 5 is equal to -100 plus 2 will become -98. And let's kind of finish this off. How would you write this as an ordered pair? Well, you would say, okay, this is the ordered pair 5 comma -98. And we know that this is in fact our solution. What if I said something like this, 5 comma 1? What would you say? Well, hopefully you would say it is not a solution. And what would this look like? Notice x squared is an even function, but it's negative, so in this case it's actually going to open down. It'll look something like this, and we could say this, hey, 1, 2, 3, 4, 5. If we went all the way down to where we hit this graph, it would hit at a height of -98. And so, hey, there is our solution. But if I said, hey, if we went to the left 5 and up 1, here would be that point, and we know that this one is not a solution. Alright, once again, pause the video here. Let's move on to our next example. Okay, example 3. Now example 3, let's get a little bit crazy. Let's say f of x is equal to 2/3 the square root of x minus 4, comma, or let's say x is 36. Perfect. Okay. Well, of course, we'll start by replacing everything with our sets of parentheses. The cool thing about square roots, you actually don't need the parentheses. We'll put our 36 there, put our 36 there. Let's start solving. Now, square roots are a little bit of a special case. That is, of course, something you will want to break down onto the side. And we know 36 breaks down in 2, 6, and 6. And there's our pair of numbers. So we could say this. F of 36 is equal to 2/3 times 6 minus 4. And I would ask you, what are you going to do with that 6? How are you going to make it a fraction? Yeah, we put it over 1. Now remember, one of our cool tricks for reducing fractions is that we can actually say, hey, there's a 3 in the denominator, there's a 6 in the numerator, and we ask ourselves, what can 3 and 6 both be divided by? We know that 3 and 6 can both be divided by 3. So 3 divided by 3 is 1, 6 divided by 3 is 2, and now we're left over with 2 times 2, which is 4, over 1 times 1, which is 1 minus 4. Now from here, we know 4 divided by 1 is really just 4 minus 4, and of course we get this. F of 36 is equal to 0. Now here's our follow-up questions. How do we write this as an ordered pair? We say 36, comma 0 is our solution. And what if we said this? 36, comma negative 3. What could we take a guess? Well, we'd say that, hey, that is not a solution. And what would this one look like? Well, it would actually look something like 1, 2, 3, 4. Start right here. And way over here, let's call this 36. This will actually hit right here on the x-axis and then proceed to go up after that. So here is our solution at 36, comma 0. And then I asked y'all about 36, comma negative 3. Well, that would be somewhere down here. And we'd say, hey, not a solution. All right, let's move on to our last and final example. You guys, whenever I get up to like an example 4, I just want you to know, like, hey, this is almost like a bonus example. It is to like really push you to the next level, but it's not always necessary for you to watch this bonus example. So if like you're really curious or you're really stuck or you need more practice, then of course this is for you. But if you feel like you got it, then you can be free to go work on your problems sooner rather than later. And then if you get stuck, you can come back and work through, you can watch this video again, be like, oh, okay, you know, I did the first 4 problems, now I'm stuck, now let's go finish the video. Okay, so here we are, we're doing everything that we've been doing. I replaced my x with a parentheses, I put in my 5, perfect, and let's check it out. We now have y equals 10 minus 4 times, well, recall 5 cubed is really 5 times 5 times 5, which is 25, remember 5 times 5, 25 times 5, which is 125. Now from here, you may need a calculator, or if you could start to do this by hand, it would really help you out. 125 times negative 4 will of course be a negative number. 4 times 5 is 20. 4 times 2 is 8, plus that 2 is 10, and then 4 times 1 is 4 plus 1 is 5. Aha! So 10 minus 500. And remember, tens will change the 10 position. So if this is negative 500 plus a positive 10, it will go 10 units more positive, which would become negative 490. It is beginning to move us towards that direction of 0. Well, lastly, how would we write this as an ordered pair? Well, we'd say 5, comma, negative 490. And you're probably thinking, Mr. Hastings, how in the world are you going to graph something that wild? Well, let me show you. Last graph. So I draw this right here. I notice this is an odd function, but it's a negative odd function. So instead of looking like this, it's going to have to look like that. And I see that this is positive 10. So let's say, hey, positive 10. Okay. And now what we're saying is this. We're saying if we go to the right, 5, 1, 2, 3, 4, 5, and we go all the way down, we won't hit this line until it goes down a distance of 490. And so here is our point, our ordered pair, 5 comma negative 490, and of course we know that that is our solution. And if we put a point out here, or point over here, or point over here, we would say, hey, all of those are not solutions. I hope that this was very helpful, and good luck, and I'll see you in our next section.